Good morning to our audience in Geneva, and depending on where our online participants are, good afternoon, good evening, and welcome all of you to this session, which is about critical and strategic raw materials. We have two sessions on this topic. This is number one. And in this session, I, together with Heinz, will be moderating the session. Heinz Böni from EMPA, and I'm Shahrzad Banucheri from the World Resources Forum, one of the organizing, part of the organizing team of the conference. We will have 6 presentations in this session, as the other scientific sessions that you have probably participated in the 3 days of the conference. The session is divided in 2 slots. The first 3 presentations will be on the first slot. After each presenter will have 8 minutes to introduce us to their work. After each presentation, there will be 2 minutes time for clarification questions if there is any specific points regarding the presentation that there are specific questions for that presentation. This will be asked, you will have 2 minutes to ask these questions. But after the first 3 presentations, there will be a kind of discussion round, 15 minutes discussion round with the first 3 presenters, that you will have more time to ask questions and open to a more in-depth discussions with the 3 presenters. We have a small change in the order of the presentations today. We will start with Mona, Jessica, and previously it was planned that Harry would give the 3rd presentation, but today we have a small change. Hello. This will be continued in the 2nd slot by Damien, Sam, and Harold will actually change his place with Harry and will be presenting in the 1st slot. I will moderate the first part of the 1st slot of this session, and Heinz will moderate and chair the 2nd part of the session. So with this, I would like to give the floor to Mona. The first presenter is Mona Arnold from VTT Technical Research Center, Finland. Mona's presentation will be about urban symbiosis concepts for sustainable circular loops of critical raw materials containing products. Thank you, Mona.
Sorry. Thank you. There should be a V.
Yes.
Obvious abbreviation of Technical Research Center Finland. Thanks. Okay. Oh, sorry, the microphone, of course. So in the next 8.5 minutes, I will go through the urban symbiosis concept for circular loops of critical raw materials, and staying on the product level. And although this is in pluralis, I'm gonna stay on go more on one case, which is the e-bike. So we're specifically looking into what can the city do. And the reason for that is that today the majority of the global population, they live in cities and generating 80% of the global GDP, which makes this a hotspot for consumption and waste, though it covers only 7% of the land area. Cities generate 70% of the global waste generation. So we wanted to explore sustainable value creation models in cities that could keep these CRMs in a tighter loops, and specifically looking at the extended lifetime of these typically high technology products. Today, it's by no means circular. With for many materials, less than 3% are recycled. And by reusing products or recycling the materials, this could provide a significant indigenous supply of these metals. This is not happening today due to there are both technological, economic, and regulatory barriers. I mean, the materials are very diluted in the products, which means like how do you design a process for the recovery, and how do you get the economy of scale for such recovery? And also we have the EPR issues. It's not that the original equipment manufacturer are so eager to give out like what they have put in where in their components. So the e-bike as a case, and we selected this because, I mean, we have, of course, car vehicles, but a lot has been done on that. E-bikes, not so much. And it's a really strongly increasing market. Shimano is foreseeing 22% growth per year. And today it's a very linear market. And we see that there's an opportunity to grow the circularity, increase the circularity while the market is growing. And it does contain CRMs in the traction motor, which is, let me see, the light goes, nope. Well, traction motor there in the middle, and the batteries and in the screen. And today, the materials are basically sourced from China, Japan, and some from Latin America. So here is the traction motor, which is one of them, which is one main component or part, and they have the permanent magnets with critical content: boron, dysprosium, neodymium, praseodymium, and also other valuable metals in the casing and cables and so forth. There's been a change here, and the European Raw Materials Act that came out this summer, or was it the spring, is now specifically looking at the permanent magnets. And in the future, the producer is to give out the information, how much is where. And based on this information, there might be in the future some criteria under recycled content to be put on the market in Europe. So we're getting there, but not yet. Then the e-bike batteries, they are mostly lithium-based, and although for the biker it seems like a very heavy item, you still are far away from an e-vehicle battery. You take it needs 130 batteries, bike batteries, to make one e-vehicle battery. So we are talking about different scales, although the components are very similar. So although lithium is it's an essential in the batteries, it's only 1 to 1.5% of the battery content, which means you can get 40 to 150 gram max per battery when you recycle the material. Today, EU is fully independent, dependent of the imports of battery cell, and also here we have new battery regulation coming. But as I looked, this will maybe not be valid for the e-bike. I think most of these are smaller than the ones that are where you required a product passport and also in future recycled content. So what can the KIC city do? How can they support the 9R strategies when you're building up a business ecosystem, a circular economy system? And here I listed the 9Rs, which we are all quite familiar with, I suppose. We're looking at from the up going down towards more linearity. And there it's actually, though they by definition cannot take part in businesses, they have to stay on the public, non-commercial side. There's still a lot a city can do. And although they have, for once, a very direct impact, they are procuring, and there are big procurers. So they have a strong buying power, and there with the green procurement, they can really shape the market. They can also do zoning strategies and regulations relating to mobility, supporting lighter vehicles, and also putting up circular economy hubs. Putting up sharing platforms, not only supporting, but maybe also putting up the actually digital platform, and putting up capacity or participating capacity building, education, awareness raising at school, but also vocational training, because there's a big lack in, for instance, the knowledge and professionality of remanufacturing and repair. We have job creation programs, putting up repair shops, and social and eco enterprises. Here in the end, we put up a circular e-bike ecosystem as an example. These are based all on interviews that we made with different public and private partners. So we have the city here who's doing in the traffic planning decides to put up a city e-bike platform, which is procures from the leasing operator who buys the bikes from the manufacturer that then gets the components from the component manufacturer. And when in this procurement, putting up really strong sustainability criteria, you have this loop here behind. We have the battery manufacturing and maintenance and repair service provider, collected material recycler, and in the end, if it really goes well, the secondary material goes back to the component manufacturer. So here we have loops of both value transfers as services and value transfers as products. I want still to add one more line, and this is essential. We need the data. We need data to flow between these different entities in order to have the whole business ecosystem really to work. And today here is really, there should be one here as well. This one is not existing. So this is so the maintenance, but remanufacturing, it's really up to, it's slowed down by lack of information, what is actually there in the components. I think I have one other ecosystem to show you, another example, but there is no more time. So thank you for your attention.
Thank you very much, Mona. Also, many thanks for keeping the time to 8 minutes. Are there any questions, any burning questions for Mona now? We have 2 minutes for clarification questions, but we will have 15 minutes at the end of the first slot for more discussions. Please.
Julian Hilton, just a quick question. The Paris referendum, which banned the use of e-bikes, is that going to make a mess of some of your market optimism?
No, I wouldn't say so. I wouldn't say so. When I look at, well, we've been basically interviewing Dutch and Finnish companies, and also actually Swiss, and they are all like seeing the e-bike is there. Then how sustainable it is, who is moving over from where? Is it from public traffic to e-biking, which is not, or is it from car drivers to e-bikers or walkers to e-bikers? Then of course that's in a different discussion.
Julian, I hate to disagree with you, but they're not bikes, they're just scooters. Because they became a bit of a nuisance in the city.
Yeah. And that's not,
it's only the scooter.
Yeah. And I think Utrecht did the same with the scooters.
Yeah, it's just that there is now a discussion kind of if there is a difference between e-scooter, e-bike, what does it mean for e-bike use, why e-scooters are hated, e-bikes accepted. So it's quite a big topic.
I can talk long about that, but that would be over a glass of wine.
Okay, thank you so much. Thanks again, Mona. Then I will ask our next presenter.
There will be.
So just our next presenter is Jessica Battle from WWF Switzerland, presenting her research on circular economy, critical minerals, and deep seabed mining. Please, Jessica, floor is yours.
Thank you. Thank you so much for having me here. So just as a caveat, it is not my research. It's research that WWF commissioned to underpin the advocacy we do on deep sea mining. So as we all know, the transition towards a net zero economy will require large-scale implementation of low-carbon technologies. And there are concerns about whether the availability of these minerals will be a bottleneck for the green transition, prompting discussions about opening new frontiers for mineral extraction. And one of the most controversial such frontiers could be deep sea mining, opening the deep sea to mining. The deep sea is a fragile ecosystem, and we conservationists are very worried about the implications of opening this frontier to a new destructive industry. So we wanted to find out how to decarbonize with a much less extractive future in mind, a future that would avoid opening the deep sea to mining, but also avoid opening other fragile ecosystems to mining. So many low carbon technologies today depend on these critical minerals, and the total demand for minerals and whether critical minerals will become a challenge for the green transition will depend on the path we take. The study looked at nickel, lithium, cobalt, manganese, copper, platinum, and REEs. And these are then minerals that could be extracted from the deep sea. There is no mining in the deep sea today, by the way. So we commissioned this study, The Future is Circular, Circular Economy and Critical Minerals for the Green Transition, from SINTEF, a European-based research group with a seat in Norway, looking at supply and demand projections for these minerals up to 2050. And the questions we needed answers to in order to counter the arguments from those who think that deep sea mining is a really great idea were, will we have enough minerals to fuel the green transition? How will mineral demand change with different technologies? How much can we reduce the demand for minerals with circular economy strategies, such as those Mona talked about? Is it possible to provide a significant amount of minerals through recycling? So technological choices will shape the demand for critical minerals. I think I probably jumped a bit too quickly. Yeah, sorry. Technological choices will shape the demand for critical minerals. So we wanted to know how technological choices can alleviate the mineral demand. And SINTEF applied 4 different scenarios to evaluate how different specific technology mixes could have an impact on the mineral demand. And they based this on the capacity of each of the broad technology categories that the Net Zero by 2050 report from the IEA had put forward, and the projected evolution in the following sectors, which is wind power, solar, electric vehicles, and hydrogen. The 4 scenarios that are here are the first describes what would be the mineral demand if we choose the same technology as we have in 2021 when the data that they accessed was available. A business as usual scenario where you look at that sort of that trajectories and learning curves and industry signals that were there in 2021, so sort of business as usual, but nothing really innovative. A resource constraint for battery mineral scenario where chemistries that are low in critical minerals are the majority of the installed capacity, and an advanced technology scenario where new technologies that are low in critical minerals really take off and become a main share of the market share of annual installed capacity by 2050. They also added in aspects around the circular economy in the study and combined the circularity options, all of those that Mona listed, into 3 main strategies: reduction in demand, lifetime extension, and recycling. So here we got this report. This can be accessed through our website, and if you would like to see the link, I can provide that after the presentation. I'm going the wrong way. That's the problem. So the finding in the report, we can reduce these minerals the demand of these minerals between 20 and 58% from now to 2050. But of course, that means a lot of choices. But with new technology, circular economy, and recycling. And this, of course, would avert potential bottlenecks in future mineral supply without initiating new harmful extractive frontiers such as seabed mining. It's interesting to see that circular economy models can reduce the demand by 18%. And a lot of this can be done between now and 2030 through lifetime extension in technologies, for example. And that can be done already today, not too difficult to do. And as stocks of minerals then grow, you can do more and more recycling. And by 2050, all mineral demand can likely be met through a circular economy. But until then, importantly to note, we do need some more mining. And so this mining in the short and medium term can be fulfilled through confirmed and technically viable terrestrial sources, applying responsibility standards, which is not the case today. So also the mining sector will have to do its part in the near future, but only until we have a circular economy. So some of the these are some of the projections on the technological choices on and mineral demands. And so technological choices can reduce mineral demand up to 30% between now and 2050. That's not a small reduction in demand. And so shifting to technologies with less critical minerals, adopting different chemistries for EV batteries, for example, moving away from lithium-ion batteries for stationary applications, and increasing the use of electric traction motors and wind turbine generators with low or no rare earth elements are really important parts of this and will all contribute. Importantly, we don't know what the technological choices will be in 15 years. And this report would have looked very different 15 years from now. And this very, very moving space. And I think this is really important for policymakers to understand that the technology is actually moving much, much faster than the regulatory framework. And so I think one of the sort of conclusions from us here as we work with policymakers is to try to make the linkages between the researchers who are in the forefront of new technological advancements and the policy development in order to really try to alleviate our footprint on the planet, which is of course what this conference is also all about. And there are many technologies in early stages of development, in R&D. And we have, for batteries, for example, we have solid state batteries that are moving from the R&D phase now into pilot production phase. And some companies are saying that in 3 or 4 years, commercialization of solid state batteries, with much lower content of some of the critical minerals, will be on the market. Some of the car manufacturers like Toyota and Volkswagen have said that they will have vehicles with solid state batteries on the road already in a couple of years' time. Many others say by the end of the century, but still this is all in the making. So lastly, of course, as WWF, we work in the influencing business, we like to say. So we used the report and made some policy recommendations for governments, but also for business on what needs to be done based on the findings of this report. And I guess I'd like to just end by saying that ultimately the choices that are being made by policymakers and businesses through their investment decisions will shape and define the mineral needs for the future and into 2050. But it is clear that the path ahead, if we do want to reduce our impact on the planet and on people as well, is a mix of technological innovation and changes to the current consumption patterns with the big waste pile at the end of the linear production that we see mostly today. And as WWF, we believe this is really within our collective capacity to reach, but it needs a lot of collaboration and a lot of thinking. So I'm really happy to be here today to talk more about that. Thank you.
Thank you, Jessica. We have 1 minute for any burning. Yes, please. Question.
Yes, thank you for the talk. I have a question regarding the demand scenarios you showed for the various critical minerals. They all showed a more or less obvious double peak. One peak between 2030 and 2040, and another one between 2040 and 2050, which was even larger. What's the explanation for this? Is the first peak the transformation in high-income countries, and the second peak
exactly.
the transformation in the rest of the world?
Exactly.
Okay.
Yes,
okay.
that's
okay.
it.
Thank you.
Good question.
I answered my question.
Okay.
Okay.
Okay. Thank you. There's one question over there.
Session after the next presentation, we will have 15 minutes for more in-depth discussions. Would that be okay? Perfect. Thank you.
Two more.
One more.
Yes.
So it was last minute change, so we didn't change the order of the presentations. So our next speaker is Harald Ulrik Sperdo. He is from Inland Norway University, and the title of his presentation is Assessing the Sustainability of Supply and Use of the Technology Metals and Antimony, Bismuth, Cadmium, Germanium, Gallium, Indium, Selenium, and Tellurium. Please, Harald, floor is yours.
All the hilarium metals. So these are the technical, magical metals that make our technology rather advanced, and we can do these things. So the methods here is to gather data, to use an integrated assessment model, and then also definition of sustainability. And so to go on, we use a large model called World 7. So it's a model that relates a lot of things to each other. Economy, demands, what pushes us to extract and mine and refine and supply and also recycle. So you need a large system to count it all up. You can try to do it on your fingers, but computers have millions of fingers. So it's better to do it that way. We're going to utilize the resource part of it, which has different metals and materials. One of our challenges with these magic metals is that there are no mines for them. You can't go to a tellurium mine or a germanium mine. They don't exist. Actually, they're secondary minerals. They depend on the big 10 metals, the copper, iron, nickel, the ones we make in millions of tons. They depend on when you've done phosphate and then what some call junk, you go and get that. And from the junk, you can get it out. Or you can get it out of hydrocarbons. Actually, when you've burned the coal and you're ready to take all the ash out and dump it, somebody says, hey, wait a minute. Now we're going to go there and find the magic metals. This does something for it, though, because also when, for instance, with germanium, here's a typical flow chart. And here we also need to remember when we talk about circularity. So in this one, you can see there are circular loops. There's flow from the primary to the secondary residuals, and then you mine the residual, and then you get germanium out. And then it goes into the different uses, and it goes to many uses. So one big new use is photovoltaic, but it doesn't mean the computers go away and the LED lighting, it's also expanding. There's several competing uses. So we need to consider this. And then when we recycle, every transaction has losses. So circularity is only half circularity. And we need to think about the yields, because some of them are tricky to recycle and you're not successful. And here we can see with simulation for selenium, for instance, here's the demand. Here's the modified demand. So when you have demand, then there's a price feedback. If it's really expensive, you're going to adjust your wishes down. This is the difference. Here's what I call soft scarcity. I would like to have it, but I can't afford it. Okay. Society can handle that you can't afford everything you point at. So the adjusted will be delivered. But if you look at germanium, we have different uses into LCDs, into photovoltaic, to IRs, infrared sensors, there are many uses. And what we see is the solid line and the thin line. This is actually supply, and this is my original demand. There's a huge gap. And to understand what is scarcity then, so I define, here's what we want, here's what we can afford, that's soft scarcity. Sometimes you can't get it. You know, shop is empty. You say, I'll pay more. Well, shop is still empty. This is hard scarcity. It's physical scarcity. You can scream as much as you want, but you won't get it. That's harder to digest, and society is not prepared for it. And we can see here indium. So this is the business as usual. and then different other demand scenarios. And here's actually what gets supplied. Even the lowest demand isn't going to be fulfilled. There's going to be part of it soft scarcity, and indium actually gets into hard scarcity, empty shop. And we can see here, what does that mean? If you look at the photovoltaic demand, we have projections, or should we call them fantasies, of how much photovoltaic we want. Okay. As long as these metals are involved, we can't supply them all. There just isn't enough material. We could probably up it a little bit if we said, you know, goodbye to phones, goodbye to computers and all that, but I don't think we're going to do that. So here we have the shortcomings. So my final message is, at present, the handling of them is linear. The recycling is, well, we talk about it, but we don't do it. Recycling rates are like 6% or 4% or 16%. It won't do the job. So it's non-existent. And they have small resources, so we can't really afford to waste them. The recycling also has low yields. They're notoriously difficult to recycle, so you need a lot of energy, and success rate is not very high. How am I doing on time? I'm fine. Okay. And that means in a little bit longer run, we will get into physical scarcity. And actually what we see in the assessment is that between 2040 and 2090, a lot of these scarcities will just come one after the other. So then we got a large traffic jam of resource challenges if we continue with business as usual. So what I can see is business as usual is probably the worst case. So what we need is business as unusual. Thank you.
Thank you very much for especially keeping the time. So now we have time for 15 minutes discussion. We have our three. Oh, sorry. Yes, if you have any specific questions for this presentation, yes, please, Mona.
Very nice presentation. You were very brave in forecasting until 2200, and you were saying like you were like putting out like business as usual and business as unusual. Well, I predict that the business in 2150 going to be unusual. So that's interesting how you've been. This is probably going into details, like how did you forecast the technology development and the need for metals so far ahead, as opposed to wind turbines are going to look a little bit different at that point?
We've made considerations on these things. It's a large model, so it has other societal parts, and so we drive technological development with investment into research, education, you know, in the larger system. So business as usual also means that there is technological progress and development, efficiencies, improve these things. I do think it's very necessary to go to at least 2200. And this is actually demanded from us by the definition of sustainability. It's about us, but also future generation, not the next generation, but future generation. That means quite a lot of them. And that means 2200 is maybe the shortest time period we can allow ourselves. Probably should do longer.
Other burning questions for
Thank you very much. Lorenzo Cremonezza from PTX Lab Lausitz in Germany. It's very similar to the previous question. How could you be so precise in forecasting not only the business as usual, that I guess it's a little bit easier maybe, or it's possible to model, but the supply till 2200. You show this diagram of indium supply. It goes until 200 years forward. I think this is a combination of new virgin material and recycling. Still, I find it. I mean, can you say a few words about how precise or how accurate can be that forecast till 2200?
But when you make these kind of predictions, they are actually not really accurate predictions. So they're not intended to be precise. They're about orders of magnitude. And also remember, they work in the same way as weather forecasts. They show what can happen. There's no guarantee it will happen. But it's better to do the forecast than not. So, because if you don't, well, then you sit there in the dark. So I think we're forced to do it. So that's why I risk to do it, because I think we should. And of course, when you get then provocative results, okay, one effect of that is to set us all off thinking, what if this is true? Okay, what do we do with it then? What if it's not true? What is then true instead? So it forces these questions on us. And I think that's a useful process.
Okay, thank you so much. And now let's open the discussion. For our three first presenters, I would like to ask you to come in the seats in the front. And I will start with your question because you wanted to ask a question in the previous round. Please, you can start and then we will go the next questions.
Okay.
Hello. Yeah, I'm a PhD student in critical raw material for the EU, let's say, the one we until 2050, like any material actually, many mineral. But my question was about deep sea mining. Some might advise that we already use inland and we already destroy part of it. We could spread damage on the ocean, so we don't only destroy land, but also the ocean. So that's kind of fair share. Why not? Yes.
Well, where to start with a question like that? I think we need to learn from our mistakes, that what we've done on land is not working. And then we are not going to solve the problems that we are having with resource use by opening a new frontier. We also know incredibly little about the deep sea. We know from every dive that scientists take down into the deep sea, they discover new species. They've started to discover the interrelationship between the deep sea and the functions of the deep sea and climate regulation. And so one of the reasons for companies, what they maintain as a reason for companies to promote seabed mining and would like to extract these minerals is for the green transition. So if you do the green transition at the same time as you're wrecking a natural ongoing process that is helping us to mitigate climate change, doesn't seem very smart. And so we must try to find other ways than opening the deep sea or any other areas for extraction. So it's not an either or, it's not, but it's also, we can't also compare apples and pears. But the most important thing and the root of the problem and the interest of going to the deep sea is our insatiable appetite for new raw materials. And that's what we need to change.
Okay, thank you. Yes, please.
Thank you. Damien Jurko, University of Technology, Sydney. I enjoyed all three presentations, and I was interested, Harold, in your use of soft and hard constraints. Shops empty or price is high. And I think that's a really constructive, or perhaps in the reverse order, price is high, shops empty. I think that's helpful in socializing this work with a broader audience, including policymakers. So I'm interested to know, have you had good reactions or responses from policymakers? And indeed, do other panelists think it's a helpful framing to advance different stages of alarm and different responses that we would put in place in each of those time periods?
Well, I think when it comes to decision makers, I think we're still in the education process with decision makers, getting them used to the concepts, internalizing that the problem is not too small supply, the problem is too big demand. But these are ways to explain that to them, but also it's also about strategy, because society handles soft scarcity far better than hard scarcity. Hard scarcity makes people irritated and times aggressive. Soft scarcity, there's an acceptance for.
I think, Jessica, you also wanted to add something.
Yeah, thank you. I just want to add a little bit. It's almost making this maybe a little bit more into a discussion, because I also really like this, that the shop is empty. It goes back a little bit to the question I was asked earlier as well. Scarcity is the mother of invention, right? We can choose to find another place. The moon. We've been talking about mining the moon for minerals, or something else out in space, which would be really energy consuming to get to in the first place. All of these new technologies, or these new resource areas, have also big energy consumption problems. How are we actually going to get those minerals? But I think this idea of scarcity as a source for innovation is really, really important. And I'm just wondering if this is something that's not talked about enough. So it's more of a philosophical question than it is an answer to any questions.
Just one comment still on the soft and hard scarcity. I believe that before you have hard scarcity, you have the soft scarcity. And when the price, that means that the price is going up. That means that this path, nobody is ready to pay for it. So they're looking at a different path. So I think actually the way that human beings are so innovative, you then still find another path to go. And so you will not actually ever, I believe that you hardly ever really find yourself in this really hard scarcity. I mean, looking at, well, very small, looking at, for instance, when you have an embargo on a country who is providing raw materials globally, it doesn't take many years before, we don't need that country anyway. We found other places to source from. So, this has been taking place with plastic waste, for instance. When China put a stop, it didn't take long before we had the plastic recycling taking place in Europe. It was just there, and then it was actually maybe not such a bad idea that they put this embargo on. So, do you want to comment on this? How do you see the soft and hard scarcity?
Yes. So, there are actually 3 minerals or metals where we today have hard scarcity. It doesn't happen every day, but it does happen several times a month: iridium, palladium, and rhodium. There are days when you can go in there and ask for it, and the shop is actually empty. You can scream as much as you want, but the shelves stay empty until some comes in. We see that also, that the prices on these 3 metals is fairly hysteric, up and down by a factor of 10. So, which stresses a lot of people a lot. So this shows that it can happen. And as we see in our predictions, it's likely to happen unless we change something with maybe a dozen more fairly soon. So we need to prepare for it. And I think we need to think about that when we talk about change, we need to prepare the ones that are to change. So the citizens, they need to be prepared for it. You can't ambush them with it. That's going to give a backlash. And this is here, so we talk about 3 arenas. we sit here, we represent largely the scientific arena. And it's not going to be the problem arena. We can solve and calculate and design. The communication arena is a huge challenge. The political arena is a huge challenge. I don't know how to turn those. I can win the scientific arena, but those two other ones needs also to, we need to win those to have real change. So we need to think about how we phrase our message, what kind of metaphors we use, and that we use metaphors that are understood.
Thank you so much. I know there are, if it's very short question, 1 minute, we can ask for 1 more minute from Heinz because Heinz will lead this next session. Otherwise, I know Harald needs to leave, but you said your colleague is around if there are any questions. Okay, perfect. And Mona and Jessica, I guess you will be staying, so there will be time for further discussion. Jana, do you want to ask your question?
Yeah, thanks. Thanks a lot for interesting presentations. I'm Jana from Norge Mining, Norwegian onshore mining company. And there was the question on Jessica. If in your research you were distinguishing between deep sea and seabed mining and how you see the differences of that, and if your approaches to whether or not to pursue with that are different.
This report is looking at the supply and demand of minerals that could come from deep sea mining. So if that answers your question. So deep sea mining is taking place below 200 meters of depth. That's where those minerals are generally found. They are not found in shallow sea. You find other minerals in shallow seas, except that we have understood that in the Baltic Sea, there are actually such minerals as well buried in sediments that could be of interest to mining. But in general, it's deeper down than 200 meters. That's the definition of deep sea. And it's also so that most of the mineral resources that are being looked at are actually in international waters. So there's also a regulatory and governance challenge that, and a specific body set up to manage that mining in international waters.
Okay, thank you so much. I know there are lots of other questions, very interesting discussions. Thank you so much to the first 3 presenters. Now I will give the floor to Heinz, who will chair the second slot of this session. Please.
Okay, hello also from my side. We start with Damien Jurko from the University of Technology in Sydney, Australia. He will talk about considering the role of responsible sourcing certification battery mineral value chains. Please, Damien, the floor is yours. And the time is running.
Thank you very Thank you very much, and greetings to everybody online and here with us in the room in Geneva. It's great to see so many people here, and I would like to begin by acknowledging the contributions of colleagues to this work. Rusty Langdon, who did a lot of the heavy lifting alongside Stephen Northey, who's also with us here in the World Resources Forum, as well as other colleagues from UTS, the University of Melbourne, and Curtin University. Thank you. Well, I feel like I have the best job in the world to work alongside great colleagues at UTS. I come from the Institute for Sustainable Futures, where we pursue a mission to create change towards sustainable futures in partnership with government, industry and the community through applied transdisciplinary research in sustainability. And that ranges from work on around sustainable finance, business economy and governance, to resource stewardship, which is a focus for today's talk, as well as energy futures. And indeed, the energy futures team have just today launched the One Earth climate model results for the G20 to look at decarbonisation pathways to 1.5 degrees. So the focus for today's presentation is to tell you more about a project that was undertaken as part of the Future Battery Industries Cooperative Research Centre. So this was established a few years ago now to bring together universities, industry, supported by further national government funding, to bring, in effect, the battery ecosystem to life in Australia. So It's got an emphasis on mining and a little bit further downstream, and looking certainly towards the circular economy. So why such an important topic? I think by day 3 of this conference, we've already heard about the huge demand that is going to be needed for, here you can see in the purple, electric vehicle and a battery storage. And this is 2040 versus where we are today in 2020. And it's really saying, how can we do this necessary work of this sourcing well? Quick poll, how many people have heard of the conversation from where this article is taken? That's almost double digits, fantastic. So this is online, more or less newspaper style site where academics can write short articles about their work and to communicate with policymakers and the public. And it's a nice opportunity, I've found, to have your work picked up by a broader audience because it's Creative Commons. So this article was by Rusty Langdon, one of the report co-authors for this work, and Elsa Dominish. She gave a great TED talk on this topic in Sydney recently, and their findings were threefold. Firstly, we can't forget to moderate demand, to reduce the total demand for these metals. To limit impacts from mining, very important. And the third pillar is also responsible sourcing, and that's what we'll go into more detail about now. So the projects on responsible sourcing that are auspiced through the Future Battery Industries Cooperative Research Centre, the one on the left, I'm leading with an element on understanding the landscape for responsible sourcing certification and what will that mean for Australian industry. Getting better resolution and data and insight into life cycle inventory data, particularly in Australia, to better evidence claims. And then companion project looking at how do we build that trust through the supply chain, through traceability. And another piece of work, technical work on geochemical verification of provenance. So testing, yes, I know the elemental composition of this mine, I know where it's come from. So our work has got multiple partners and from university and industry, and just leave people to spend some time looking at this later. We probably need to move it along here, but there'll be work on benchmarking and footprinting and so on. But today I want to bring us to a report that we have available online, which compares the certification and sustainability assessment approaches for battery materials. And the reason was just to help make sense of this, particularly for industry who's grappling with how do we go about it, and if we are already doing some work here, will it be much more of a further step to aim for certification? So just a brief overview of all the ESG themes which we identified there. You can see across environmental, social, and governance categories. But the heart of the work is really this comparison table. So in the columns, you have the different approaches, and down in the rows, all of the different dimensions of reporting that people would need to do. And in the sort of deeper colors for the heat map is where there are multiple indicators that approach would need to be reporting against. Things like air quality, energy, greenhouse gas, cultural issues, and so on. And just to draw attention to a couple here, one on greenhouse gas reporting, where there is some variation between scope 1, 2, and 3, across the different approaches, and similarly water, where there's more significant variation. So go into some more detail and jump and download the report, and we can talk some more. Where we are now in this project, which has still got another 18 months to run, is doing some further interviews with people who've had experience in things like adopting IRMA and what's been involved to help give a sense of well, in effect, the cost-benefit ratio for others to join, and we'd like to see more experience built up around things like that and how it relates to regulatory approaches, particularly in different jurisdictions in Australia. More life cycle inventory data and hotspot analysis and so on. But I wanted to finish here just with a reflection question for us, and to think, how will our conceptualization of responsible sourcing change as in the primary sector, coupled to renewables, done well and certified? How does that sit alongside recycling and urban mining and recycling done responsibly? I think it's a nice moment here, Sam, I know, speaking next also about recovering value from tailings and mine waste. So how does that sit into the landscape? And I think how this is framed and understood, I think it'll be good for us to explore and then take that work forward. Thank you.
Thank you very much, Damien. You were well in time, a bit more than 8 minutes. So we have time in 2 minutes left for questions as regards to the presentation, to understanding the presentation. Please.
Thank you, Mr. Chairman. My name is Michael Haschke from DMT. I'm just wondering what made you decide on IRMA, the US standard? There are other standards out there that fulfill all these criteria.
Oh, not only. We'd be interested. We're talking to the Minerals Council of Australia and towards sustainable mining, and it was one of the ones we looked at, but certainly we'd be keen to build up a comprehensive picture and talk some more. So it's not a picking winners exercise, but certainly the dimensions of that which stood out in some of the work were the multi-stakeholder views that were feeding into what good looks like. But it's an open question for how do we get broad adoption as well, and they're both important dimensions of getting it to our ultimate goal of better environmental and social performance.
Thank you. You also mentioned tailings recycling would be an option. There are studies out there that say that around about 80 to 85% of all tailings cannot be reprocessed economically. There are a few examples, and I will be talking about one later this afternoon, and you're more than welcome to join. But overall, tailings recycling has been proven to be rather uneconomic, also, of course, depending on the raw materials prices. Thank you.
Thank you. That, in fact, wasn't such a focus for our research, but was a thought prompted by some of the work going on here at WRF.
Okay, thank you very much, Damien. And we come to the next presentation from Sam Whittlesey from LGI, Sustainable Innovation France. He will talk about the BioRecover project. Please, Sam, go ahead.
Hello, everyone. So I'm really glad to be here at the World Resource Forum talking to you about the BioRecover project, which, as was just mentioned, is looking at reprocessing different extractive waste streams using biotechnologies in order to recover critical raw materials. So today we're going to be talking about essentially the exact same challenge that Damien just mentioned, which is how do we sustainably provide the critical raw materials that are necessary for the energy transition? And how do we simultaneously address the problem that producing these materials generates, which is exponentially increasing amounts of extractive waste? So today I'm going to be focusing on one of the extractive wastes that's addressed by the BioRecover project, which is bauxite residue, what's otherwise known as red mud, which is a byproduct of the Bayer process, which is used to produce alumina. So every ton of alumina produced generates between 1 to 2 tons of bauxite residue. This is a highly basic material that's piling up around the world. And so now there's an estimate that around 3 billion tons of bauxite residue are stored in large-scale tailings dams around the world. The BioRecover project was created in order to try to address this and to develop new solutions to economically reprocess different extractive wastes. So the idea is that by using microorganisms that produce different leaching agents, we can more economically recover different critical materials and then revalorize these extractive wastes for other uses, such as in construction. So the project brings together 14 different project partners from across Europe and South Africa to look at 3 different value chains. Today, I'm only going to be focusing on rare earths, but if you want to read the full report, it's available online as well. So it's recovering rare earths from bauxite residues, as well as platinum group metals from low-grade ores and magnesium from the low-grade magnesite. The work that I did in the project was to try to bring research into dialogue with industry to analyze essentially how these technologies could transform the value chain. And so basically I did a series of interviews with different stakeholders from across the existing value chains and looked at how upscaling biotechnologies could impact their business models and what a new regenerative value chain could potentially look like. So today I just want to give you a taste of that research by talking first about what the existing rare earth value chain looks like. So rare earths, for those who may not know, there's 17 different rare earths, and despite the name, they are not necessarily rare. They're relatively more abundant than other elements that exist, such as the platinum group metals, and they're present on every continent on Earth. Nevertheless, the global market for rare earths is essentially dominated by one country, which is China. So what we see is that the value chain has evolved over the past 2 decades. Previously, China dominated both mining and then refining, and that was used to essentially then gain a monopoly position as well in high-tech manufacturing using rare earths. That's evolving. So now mining is being outsourced to other countries around the world. So here we have an image from Malaysia, where a lot of heavy rare earths are being extracted now. That is coming with enormous environmental consequences, as essentially they're leaching the rare earths out of the mountainside directly in situ using harmful chemicals. The rare earth value chain also faces some vulnerabilities due to the fact that it's so concentrated. So here on the right, you have a price graph from 2003 to 2013. And the line in December 2010 to early 2011 was when China decided to implement certain export restrictions, which basically completely destabilized the global market for rare earths and triggered the global discussion around critical raw materials. That's when Europe published their first list of critical raw materials as well. So, given the fact that the current system is not necessarily sustainable, what could an alternative value chain look like? So rather than focusing on all 17 of the rare earths, today I want to talk about one rare earth in particular, which is less well known, which is scandium. The global market for scandium right now is around 20 tons. So if you haven't heard of it, that's probably why. It's a very niche metal, but I think it has a lot of potential, especially when we consider the symbiosis between scandium and the aluminum market. So scandium is present in around 120 parts per million in bauxite residues. So if we just look at Europe, we can estimate that there's upwards of 60 kilotons of scandium that are present in bauxite residues in Europe at this very moment, which is quite significant considering that the global demand is only around 20 tons per year. And scandium is particularly relevant when used as an alloy with aluminum. So if you take 0.05% of scandium, or 0.5% of scandium in an aluminum alloy, you can have very significant gains in terms of the strength of that alloy, and then that allows you to produce various applications that are much lighter weight. And so, for instance, Airbus has estimated that if they were to use scandium aluminum alloys throughout their planes, they could have 20% energy savings on the energy needed to use to operate the plane. My argument is that remining of bauxite residues can have a variety of different positive social and environmental effects given this symbiosis. So if we think of the residue as a large-scale material, of course, there's not just 120 ppm that's going to be removed. That's going to make us deal with the real problem, which is the bulk of the material. Fortunately, by leaching these rare earths out of the bauxite residues, we're taking a very basic material and we're neutralizing it, which then allows us to use that material in other applications in construction and get rid of the bulk of the material. At the same time, scandium is the most valuable of all the rare earths in terms of value by weight. So it generates enough revenue to kind of have a break even for reprocessing the bulk of the material, essentially. And doing this with different bacteria that are used for bioleaching can offer performance benefits in terms of reduced need for energy and reduced need for chemical reagents. Why has no one done this yet, you may ask? Well, that's in part because of something that came out in the study that we performed, which is this chicken and the egg issue. Essentially, there's not a supply of scandium that's readily available because there's no demand, there's no off-takers that are ready to soak up that supply. And there's not a ready demand for scandium because there's no supply. And so essentially, to get out of this catch-22 situation, what we need is a dialogue between both producers and industry downstream to build out the new value chain kind of simultaneously. We also need new incentives to reprocess bulk material to make that cost competitive versus conventional construction aggregates. And to do that, we're going to need to reframe our policy frameworks, look at issues related to waste classification and things like that. And there still is a need for continued research and development to have tailored processing routes that are specific to the material composition of different feedstocks as well. So if you're interested in this type of work, I encourage you to look us up. I work for LGI. As I mentioned, our website is lgi.earth. And if you're interested in the study, you can also find it on the BioRecover website. Thank you all.
Thank you very much, Sam, for this very interesting presentation. 2 minutes again for questions, please. Yes.
Eberhard Falk from the International Raw Materials Observatory. Did I hear correctly that you said about Malaysia that the rare earths are leached directly from the mountainside? I mean, that's the wording I seem to have heard.
Sorry, it was Myanmar.
Well, okay.
Yes.
Well, it wasn't about Malaysia, but I thought that in these cases, it's always monazite sands that are mined with a sort of strip mining technology, say high pressure hoses or dredges to take it from the fluviatile sands there. And that's what causes the impact, not the leaching.
So
I mean,
there's a really good report on this. It's called Myanmar's Poison Mountains. It's done by Global Witness. I encourage you to go look at the report. They have these large-scale ponds carved directly into the mountainside, and they've done some good work with satellite data as well, monitoring the entire area.
Okay, then yeah, I thought it was Malaysia, and I don't know about
No,
Myanmar.
Malaysia is there's another rare earth processing plant in Malaysia, the
Mm,
Linus
yeah.
plant. But
Thank you.
Yes, please.
Tias Kuman, University of Johannesburg, South Africa. You were a bit too fast. What South African partners was part of the study?
WITS, as well as the University of Cape Town.
Okay, thank you very much, Sam, for the presentation. Thoughts again? Yes, we have to change now to the last, or the first slot, yes. We come now to Hari Krishnan Tulsidas. He will talk about critical raw materials and value chain risks. He's from UNECE in Switzerland. Please.
Thank you very much for joining me and all the distinguished panelists, presenters today. I will be talking on some of the issues we are dealing. We have been discussing for the last 3 days. A lot of problems has been raised, but solutions are fewer. Critical raw materials and value chain risk. We are talking about the ESG aspects, what has to be done about the environmental, social, and governance aspect, but how it relates to the sustainable development. Sustainable development goals is something which we need more focus. Traditionally, we all know this. Traditionally, the most dirtiest activity was production of critical raw materials, rare earths elements. That is why countries which were producing rare earths or critical raw materials in the past, like US, Brazil, and many other countries, decided to push it to other countries, and it ended up in China. Not because China wanted it, because other countries don't want the critical raw materials production in their countries. So now we have changed the outlook. Now we want these critical raw materials, and we want it to be produced in all the countries which previously rejected it. So how that is going to be possible? It is very difficult. Just an example of lithium mining in the lithium triangle of Chile, Argentina, Bolivia. If you go to Chile, it is creating a lot of social tensions, biodiversity issues with flamingos. It is creating legal issues. Companies who are investing in producing lithium in any of these countries will have to face a lot of risk in their investments, and others will have a lot of risk in seeing how these materials are going to be in the supply. Like the producers who wants to have batteries will have risk on whether they are going to get these materials out. We need some improvement. We see that mining industry should improve its performance and accountability of ESG issues. We heard about a lot of ESG aspects. We heard about responsible mining, and we know that circular economy is circular economy approach, or circularity is the most effective way of achieving it. If you don't have all this circular economy, responsible production, then we are going to risk sustainable development. The energy transition is not going to happen. A lot of technologies are going to be stalled, and we are looking at innovations coming up to change the business as usual, the advanced technology models. This is not going to happen if the materials are not there, and the materials can be there only if the ESG aspects could be improved. What is presently happening is there is a strong lack of focus, a lack of coherence on ESG aspect. Multiple standards, multiple reporting formats, multiple scales of reporting, multiple geographies, having different terminologies and vocabularies which are not getting connected to each other. And this is generating a strong sense that somebody is playing dirty here. We call it greenwashing. So if you have this kind of incoherence, even if you are doing the right way, you will be accused of not doing it in the way the society wants. So what the UN Economic Commission for Europe, where I work, what we are trying to do is to generate that vocabulary, to generate that dialogue between the governments, industry, financiers, and the civil society to see that we can do it properly. So the only way we can have such a dialogue possible is to build an overarching standard which is principles-based, because each country, each region will have their own approaches to sustainability. We cannot dictate the procedures, the process, but we can say that this is our goal, this is our aim. We have to come down, we have to cut down on water consumption, we have to cut down on hazardous chemicals use, and all those things as goals or objectives we can put forward. But we can't say that you should do it exactly this way. So we have built the United Nations Resource Management System, which is a comprehensive framework for managing mining risk and promoting sustainable resource management based on the concept of linking the ESG criteria across all stages of the resource life cycle to SDGs, Sustainable Development Goals. These are 17 goals we have agreed on. And one important fact about this goal is they are interlinked, they are indivisible. You cannot have one goal achieved without having attention of what other 16 goals are. All the 17 goals are interlinked. And one area where we are particularly focusing is on critical materials traceability sustainability project, which is looking at digital technologies which can promote traceability and transparency in the value chain. And what are the benefits if the countries and companies and the financiers are using this kind of approaches? They will have reduced cost. They will have reduced improved reputation, and they will have access to new markets. So what we are proposing under the UN RMS, UN Resource Management System, is a value chain, CRM value chain SDG risk index, which is a proposal to connect the ESG factors to SDGs and measure about 30 plus indicators. You cannot have less, you cannot have more. It creates confusion. And provide guidance for improving performance and mitigating risk. We think that it will focus on maximizing the positive impacts. It brings value for the society. It brings value for the, it brings cost benefits for the company. It brings reputation for the reputation, increases the reputation for the companies, and it aligns with the Sustainable Development Goals. And we think that CRMs are vital for our future, but we think that it poses significant sustainability challenges unless the ESG risks are mapped and worked with the SDG targets. So we need to adopt a systemic approach to that, systems approach, and that is what UNRMS, UN Resource Management System, is providing, and it will provide a risk index that could be applicable to achieve this. Thank you.
Perfect. Thank you very much, Hare Krishnan. We have 2 minutes left for basic questions from the audience. Please.
Hi, yeah, my name is Mario Causa. I'm from the ETH Zurich. I was wondering, will this framework be connected to other UN standards like the Global Compact?
Yeah, we are making it an overarching umbrella standard, which will be connected to other UN goals. We have already started working. The Secretary General of UN has set up a working group on transforming the extractive industries. The co-chairs of this group are the regional commissions like us. We have sister regional commissions in other regions. We have UNEP, UN Environmental Program, and the UN Development Program partnering, joining forces. And we are collecting all the tools and approaches. And the UN Business Compact is one area where we'll be touching upon. We recently got, this summer, we got endorsement from the UN General Council. So 193 countries have accepted this model without any objections. There was unanimity in their acceptance. Thank you.
There's time for another question, an urgent question.
What?
Yes.
Yeah, basically we have looked at, we are focusing strongly on circular economy. We have looked at the standards and approaches to circular economy, and we heard presentation. The present circularity is about less than 10%, which is just a statistical error in our opinion. So we are not doing anything on circularity now. We think that the whole approach has to be systematic. There should be a system approach, and what we are promoting is resources as a service. We have to get rid of commodity models, and most of the standards and approaches are seeing it as commodities. We have to get rid of the commodities. We have to see it as a public good. We have to see it as a resource, and then there should be ownership. Every stage of the value chain, you are not tracking the materials, you are tracking the services, and this is happening in platinum industry. There is 100% circularity in lead zinc batteries, which is old technology. 100% of the zinc is being recycled. So we have some examples in doing it. Some people are not agreeing, but this is you have some good examples which we can follow.
I see there are more questions, but now we start with a panel. All the three presenters, please invite them to have a seat in front so that the audience can address the questions to the three of you. I also heard that you have online questions, right? How many do you have?
Just one for Damien. Yeah.
One.
Just one.
Okay, then let's start with this one. I think that's good that people in online also have questions.
So yes, this is a question for Damien. Could you please explain the numbers in your comparison table that you showed?
Thank you. They refer to the number of categories requiring reporting for that. So how many dimensions of air quality, how many sort of sub-indicators in relation to water or anything else, but happy if they wish to be in touch to follow up offline.
Thank you very much. Please.
Yes. Me, it's mainly for Hari Krishnan. I was wondering, like here at the forum, so we speak about mining, extraction, smelting, all the processes that are involved in raw mining, like in mining process, but I feel like a big part of the world community, mainly Asian country, are absent. How come? I feel like it's only Europe, Australia, a bit of US, but the big company we should work with are not here, not even the research academics. How come?
Yeah, that is a good question. We are in dialogue with the major mining companies. We are talking very frequently with the International Council of Mining and Metals, which represent a large majority of the mineral producers. There is apprehension, like it is like when the UN comes in with some new approaches, new standards. The first reaction is that it is going to increase the cost. It is going to make the production unsustainable. I mean, cost-wise, unsustainable. So we may become bankrupt because of these standards. And what we are trying to prove through examples, we have now working with several universities in UK. We have been supported by the European Commission to do several studies in Europe. We are working with the African Union. African Union has adopted this model as a continental system. We are doing a lot of case studies, especially in Uganda, Namibia, Malawi, and many places to prove that using a sustainability approach is cost saving rather than it is added cost to you. It will bring new business opportunities. You get new products, new services, and you have to think away from the commodities. You have to think away from the commodities, the materials, the tons of materials which you produce into the services you produce, and you start getting new ideas, and several startups are there. Mining mindset is very difficult to change, but we have young entrepreneurs coming with good ideas with startups, and I think they will lead the way, and the bigger industry will follow. Thank you.
Thank you. Please, Thea.
The question is for Sam. Sam, have you been to South Africa?
No, we have a project meeting in 2 months though.
Okay. Just for the audience, South Africa is one of the countries with the biggest inequality in the world. And it's the poorest of the poor and the most vulnerable that stays next to these tailing dams, or as we call them, silt dams. It will be environmental and social solution. So what's the economic feasibility of your study, and at what other metals and minerals did you do the study on? Thank you. Tias Kuman from the University of Johannesburg, South Africa.
So the economic feasibility, we're still at a low technical readiness level right now. So as it scales out of the lab, that will become more apparent. But right now, it's not something that's ready to be used at large scale. In terms of the issue around other metals that we were looking at, we're working also in platinum group metals, which I know is South Africa is the world's largest producer. It's like 80% of the different platinum group metals. And WITS has a partnership with Sibanye-Stillwater as well. And so I think that particularly in the PGM industry, this issue of social acceptance, also in relation to Marikana and the tragedy that happened there, and the relationship with the workforce there. I think all of these things are factors that are really essential to take into account. And if I can add one last note on this issue of legacy extraction sites, I think that reprocessing of extractive wastes should be considered something that is essential for the long-term health of those mining impacted communities, not only the people that work in those communities, but the people living around them, because of the environmental consequences that has. And also this can be a way to generate kind of a last bit of revenue that then can cover the cost of mine closure. So, yeah.
Thank you. There is room for one or two more questions, please.
Yes, my name is Jan Cosmo.
I think the other lady was there.
Yeah, you and then.
Okay, I work for the German Environment Agency, and I'd like to have a question to Damien. There have been studies which looked compared these different standard systems in Germany as well, and I'm happy to talk to that in the pause with you. I wonder, it was too fast to understand your assessment grid there, and that you and the list of ESG indicators. I wonder, these standards are very heterogeneous. They have different objectives and also different mechanisms and institutional designs. So I thought the criteria, you looked at the governance indicators for like the companies who are like audited by these standards, but how far do you look at the governance and institutional setup of these standards? And how far they're multi-stakeholder governed, or as well, are they aiming to be like a gold level, a best performance standard, or is it more like a minimum requirement standard? All these questions. And for instance, if you look at ICMM, this is like a self-obligation of the member companies. That's something completely different than IRMA.
Yeah. Briefly, because I know we had another question too. There was some exploration of that. In part, the exercise was also awareness raising in Australia amongst the industry of the diversity of the landscape. It wasn't then to have one landing point necessarily but just to help them with the navigating, including the reporting, and to give them a feeling for, if we are to aim higher, because that's what we would like to do, then how can we learn from those who've done it before, and to make the path easier, and to build really build the capacity in that area. And there is certainly work that the Australian governments are thinking about. What does it mean of us in the global context? So yeah, would be pleased to chat further and also draw on some of the German experiences. Yeah.
Thank you. Please.
Okay, thank you very much for giving me the chance to ask a question. There's a question for Sam. You were talking about as a biotechnology approach, but I think you didn't speak so much about the details of this. So I'm interested in what kind of microorganisms are involved and how does this work really in detail. So they take this extractive waste as an energy source or material source, and then they are fed with it and then they digest it and then it's in their cells? And is it processed kind of further? Is it changed further? And how do you recover it from their cells actually? So I'm really interested in what kind of organisms and how is it working really? Thank you.
Very good question. So preface is that I'm not a microbiologist, but I have been spending the last 3 years speaking with them. The BioRecover project is looking at a wide range of different microorganisms. So some of those are bacteria. We're also looking at a specific variety of fungus. There's also work on protein absorption. In all three of the different processes that are being developed, it's a multi-step process involving essentially leaching, so putting the material into bioreactors. Then some microorganisms are able to feed themselves off of the material itself. Some need an external feedstock. One of the interesting ideas that's been looked at in line with the circular economy approach would be to use molasses as a byproduct of the sugar industry to be a feedstock. So essentially, yeah, the compounds are leached out, then you produce a leachate, and then there's other microorganisms that are capable of actually absorbing the critical materials themselves, and then there's various different processing routes to extract it once it's been absorbed by the microorganism. Sorry, I can't go into details on naming specific bacteria yet because I don't want to disclose any confidential research also. Sorry about that.
Okay, thank you very much to the last three presenters for their presentation. Again, an applause, please.